All right, let's take a look at problem 4.5. In problem 4.5, you're asked, whoa, hope you just didn't get seasick. You're asked to order the following compounds according to the decreasing ionic characteristic of their bonds. Couple things. First, when we were just doing quick and dirty definitions of ionic and covalent compounds, one of the things we said was that an ionic compound is usually between a metal and a non-metal. And that covalent compounds are usually two non-metals. Well, if you look at your choices here, right away, you see two compounds that are clearly covalent. So really, the ones that we're having to decide between, first of all, are our barium and our titanium. Both barium and titanium are bonded to chlorine. Let me back up just real quickly. In deciding between barium chloride and titanium chloride and their ionic characteristic, remember your formal definition of ionic compound. Anything with an electronegativity difference greater or equal to 1.9, I think is what your book uses. Your book either uses 1.9 or 2.1. I've got two different textbooks and they use two different things out there. But basically, the greater the electronegativity difference, the greater the ionic characteristic. We said that electronegativity increases this way across the periodic table. So let's take a look. Both of these ionic compounds we're comparing have chlorine as our anion. And chlorine is towards this end of the periodic table. And it's got an electronegativity value of about 3.0. Then we come to barium and titanium. Barium is here, and titanium is here in your transition metals. Barium is farther away from chlorine, so they're going to have a greater electronegativity difference. It's got a less electronegative than titanium. Since it's less electronegative than titanium, that means the electronegativity difference between barium and chlorine is greater than that between titanium and chlorine. So barium chloride is going to be your most ionic, followed by your titanium chloride. Then we've got to separate these two goobers. Whoops, I'm sorry. The two covalent compounds. Our calcium, our carbon chloride, and our, it is late in the day. Our carbon tetrachloride and our dichlorooxide. Separating which of those is most ionic. Well, if you looked up their electronegativity values, chlorine is 3.0, carbon is 2.5. That gives a difference of 0.5. So that's actually pretty much nonpolar, perfectly nonpolar. Well, if we look up chlorine and oxygen, chlorine's 3.0, oxygen's 3.5. Well, hot diggity dog, the difference is 0.5 again. So they have the exact same ionic characteristic. So it would actually be a tie here between those two. So you just stack them up on top of each other. And that's that.